Good morning. Today we're taking a look at where we can use all those factoring skills. Right, we've been factoring since 6.1, 6.2, 3, 4, 5, 6. Learned so many things, but where do we use them? We use them in equation solving. Okay, so where do we use those factoring skills is in equation solving questions. So, but before we start solving equations, why don't we observe a very simple fact? It makes sense to us, and it's going to be great when we use them in equations. It's this: pick any two numbers, okay? But their multiplication will be 0. So I want you to pick two numbers, and when you multiply them, it's gonna make 0. Can you give me a pair you can come up with? Like 3 and 4. Is 3 times 4 0? No, it's 12. 1 and 100. No. Maybe we should pick negatives. Negative 2 and positive 2. That doesn't make 0. Negative 2 and positive 2. No, when you multiply, they make negative 4. So can you come up with a pair that's going to make 0? Come on, it's a simple question. No? 2 and 0. Yeah, 2 times 0 is 0. 10 times 0 is 0. Or 0 times 5 is 0. 0 times 0 is 0. You can come up with millions of them, but there is always a condition, restriction. One of them, at least one of them must be 0. Otherwise, if you pick two non-zeros, they will never make 0. So this gives us an idea. If there are two unknown things come together with a multiplication, by the way, there is a tiny little bit multiplication here. You're multiplying them. If two items multiply and you see them, they're multiplying each other and becoming 0, then you feel free to split this apart, separate these apart with their own zeros, because either the left piece or the right piece, one of them, at least one of them, should be 0. That's what this fact, property, rule says. Okay? So, when it comes to equation solving, look, the right side is 0. So you need to first check your facts here. You must have the right side 0. This is most of the time ignored, and there is some trick questions. You fall into this trap. You need to make sure the other side must set into 0. That's so important. If this is 1, you cannot use this fact. With this 1, this is not gonna work. You can only use this fact with only right side 0. Second, the left side should be product of two or more items. It should be in product form. So if the question was x squared plus 5x plus 6 equals 0, no, I can't use. No, can't use the 0 product rule. ZPR, 0 product rule, won't work because these are addition of 3 terms. You need to convert this into multiplication. Okay? So this is multiplication. Your right hand side 0. So I go say, yeah, we can use ZPR here. What does ZPR mean? You can simply break each piece into their own equal signs, set it into 0. So I can put x plus 4 into 0. I can set x minus 8 into 0. Everything in parentheses separates their own way and set into 0. Now how do I solve these? Solve means isolate. You need to keep going until you get x all by itself. So for this, I will subtract 4, add 8, and this way we will have x negative 4 or x equals positive 8. Okay? And these are our solutions. Again, solutions means when you enter these numbers, results, one by one into x, it needs to satisfy this equation, such as plug in minus 4 here. What is minus 4 plus 4? Isn't it 0? This guy is 0, and this is minus 12, but 0 times minus 12 is 0 anyways. 8, plug in 8. These are optional, you don't have to. This is for testing your answer right or wrong. Plug in 8 here and 8 there. I'm testing the second one now. 8 plus 4 is 12, but 8 minus 8 is 0. What is 12 minus 0? 12 times 0. It's 0. So both solutions checked out, and I'm sure we got the right answer for question number 1. So it is negative 4 and 8. Alright, here's the shortcut. It's always opposite of the numbers in parentheses. This is x plus 4, it's negative 8. X minus 8, it's positive 8. Okay? If you have simple factors, of course. If you have complicated factors, this is not going to work. If you have x and something else, x and another something else, we have opposite of those numbers. Alright, second question is similar. What is the difference compared to the first one? We do not have two sets of parentheses here, only one set. I put this question especially because most people think, oh, there's a single set into single parentheses set into, so they ignore this guy, they forget about this one, they only set this side into 0. This is incomplete. Although there isn't any parentheses on the first one, you can make your own. This is just x minus 0. If you need to make it look like the second set, the first one is x minus 0, so you can set this one into 0 as well. So each and every factor before and after the multiplication, there's a multiplication sign. Remember here, this is before, this is after the dot. Each and everything before and after the dot must be set into 0. So this is already a solution. You don't have to isolate it. It's already been isolated. How about the second guy? I add 7. And then divide by 3. Do we have to change this 7/3 into decimals? No, don't change it, because they want answers in fractions or integers. This is an integer, whole number. Don't change into decimal or Connect Math won't like it, okay? 7/3 and 0. You can put them in any order. If you wish, you can put 7/3 first, comma, and 0 next. Okay? Alright. Fun is over. Get the question. Look at the question and tell me the difference, please. If you don't notice a difference here, you're in trouble. What is the difference? This question versus the previous one, x plus 4, first question, x minus 8. What is the difference you see between these two questions? What do you say? Yeah, this has not been factored yet. Not factored. And this is factored already. So this has been cooked. This is a dish. This has been cooked for you on your plate already. You just dice it up and eat it. That's it, right? This is easy. This is raw material. You need to first prepare the meal, cook it, and dice it and eat it. This you need to work on. Well, how do we work on? Use all your knowledge you've been gathering from 6.1, 6.2, 6.3, 6.4, 6.5, 6. All 6 sections before this section. We've been developing, piling up these tricks, factoring skills. You're now fully developed those skills. Factor this with using one of the sections. How do I factor this? First thing, once I'm given a question, see if there is a common factor in all numbers and variables. D squared, 7D and 44. Anything common? Anything common here? No, nothing at all. Second thing I check is if this number in front of the square is 1. Is it 1? Yes? Then this is an easy type. This is a question from section what's that? Yeah, it's a question just like this, section 6.2. It's a factoring trinomial of the form 1x squared and some x's and some number. The key thing is it starts with 1. All you need to do is find out what numbers multiply to 15, what same two numbers add into 8. Remember that trick? That's what we are going to do on our current question. Okay. Alright, let's clean this up. Product will be, and sum will be, product needs to be negative 44, sum needs to be minus 7. Give me candidates. You can just throw in numbers here. Their multiplication will be minus 44 and their addition will be minus 7. First thing comes to my mind is 1 and 44. Negative 1 and 44 makes minus 44 when I multiply. But when I add them, they make 43. Oh, let's flip signs then. When I flip signs, this is positive, this is negative. It's negative 43. I'm nowhere close. I bet these two numbers should be close to each other. 1 and 44 are too far apart. Pick another pair of numbers close enough to make minus 7. Anyone? 11 and 4. I would go with 2 and 22 first, but these are not gonna work, okay? Just try it. Not gonna work, not gonna work. And then you can go, you said 4 and 11? 4 and 11, you need to pick one of them negative so it can become negative. Which one? Okay, I will go with opposite of your choice. Why? Because I like making mistakes. Minus 4, 11 makes minus 44. You're right, minus 44 when you multiply, but when you add, unfortunately, it's opposite of this number. But once you get an opposite of this number, you know how to fix it. Just flip the signs. Flip the signs and voila, this is the right pair. So you got it. Your pairs have 4 and minus 11 on the side. But what are the variables? Variables are D. D plus 4 and D minus 11. What's that? Okay. When you FOIL this, make sure you get these 3 terms. You know how to check whether you're on the right track or not. When you factor it and FOIL it, it needs to match the original question. Okay, next. You have product of 2 items, A and B, and set it into 0. And ZPR, zero product rule, says that, oh, you have something set into 0 after multiplication, then you can break it into 2 parts, set each individual part into 0, and solve. This is going to be D equals negative 4, just opposite of these numbers. D equals 11. and all done. Okay? Make sense? Alright, let's proceed to the next one then. We're just having more and more difficult factoring. That's it. Nothing new. You just need to use a section before this to get that factors right. Okay, in number 4, we have such a case. And immediately I noticed that the number in front is not 1. Uh-oh, are we in trouble? If you skip step 0 of all factoring questions, yes you are. You need to you need to do trial error method, you need to do grouping method, AC method, that's what we call AC method. But if you are careful, that 3 can be taken care of somehow. How? Any ideas? Yeah, look, this 3 is actually everywhere. 3 times 7, 3 times 10. So you can actually call these 3's out. It's the greatest common factor of everybody. And what you have left with is z squared, 7z, and 10. And what's nice about this parentheses expression is it's just like this question. It starts with 1. How amazing is that? That means you can take these numbers and try to guess another pair of numbers making product 10, sum 7, both positive. That's not good. Can you guess it? Is it 110? No. Bad. Is it -1, -10? Flip the signs immediately if the pair is not working. Now it's not working. I can't get it. Somebody? 2 and 5. -2, -5? No, it's -7. It's +2, +5. Good. So you break this parentheses into z plus 2, z plus 7, no, z plus 5, 2 and 5, right? 2 and 5. And what do I do with the number in front? Nothing, just move it. Carry it forward. Now what do I do next? Just don't bother this 3. This 3 serves no purpose. Forget it. You can just carry forward, do ZPR, zero product rule, and put each piece into 0. And you're done. Or some people really obsessed with this 3 and they want to handle it. This is how you can handle it. You can divide both sides of the equation by 3. And look what happens. These two cancel and 0 over 3 is 0. So if that 3 bothering you is gone, if you're really that picky to take care of that 3, look, it's gone. So if you call a factor out, it's actually can be taken completely out of the equation. It can be cancelled away. Kinda somebody inflated this equation by 3 by multiplying everything by 3. So you're reducing, taking the extra air out by dividing by 3. Alright, now let's set this into 0 again. As I said, set this into 0, set that into 0, and get z equals -2 and z equals -5. Final answer. Okay. Well, we're fast today, but again, let me know if you have any questions. Are you comfortable? Because you shouldn't be getting this fast. It's okay if you are struggling, okay? I want you to compare this question to first or second questions. Can I move first or second to here? Alright, tell me the difference, please. What do you see different? I have two sets of parentheses. Yeah, two sets of parentheses. Set it into zero, set it into zero. And almost identical questions, except how many pieces are multiplied here? 1, 2, 3. This is only 1, 2. I taught zero product rule, ZPR, saying A and B can be separated only two pieces, is valid for multiplication of two numbers. This is multiplication of three numbers, A, B, C. There is A times B times C, set it into zero here. What shall we do? I want you to pick three numbers multiplied into zero. Either one can be zero, right? A, B, C. A, B, C, one of them should be zero. So I'm saying that, can we expand this ZPR rule, zero product rule, into three numbers? If you have a third piece, can we also set that third piece into zero? Yeah. If you like, there are four pieces, you should put the fourth one into zero as well. If there are 1 million pieces, then you should put each into zero one by one. Okay? So ZPR rule, zero product rule, can be expanded into any number of factors, not just two. So you see three here. All you gotta do is set each and every piece into zero. Starting this one, it's R only, set it into zero. R minus 2, set it into zero. 5R plus 9, set it into zero. This has already been isolated, no work required, but this one requires an addition. And this one, not only addition or subtraction, but also division required here, because 5 is next to my variable, which was absent in the first two. And all set. So for the first time, we have three numbers obtained because we had three pieces. All you need to do is enter those three numbers here. Hey, I wonder, instead of 9 over 5, if I can enter 1.4. 9 over 5 is 1.4, right? Question?
Does it matter what the order is?
No, it doesn't. It doesn't matter. So 9 over 5 is 1.8, right? Negative 1.8. So let's try negative 1.8. I'm just wondering if it's a terminating ending decimal, can we use it? No, it doesn't like, don't use it. They want fractions or integers, whole numbers or whole numbers or fractions, no decimals. It's 5. Alright, we fixed it. Alright. Again, you can flip 2 and 0 if you want, no matter. Alright, what's the deal in this one? There is a way we can do when we learn about square roots, radicals in chapter 9. But until that moment, you're not allowed to take square root of both sides, so forget about that. But I want you to compare this to any number before. What's the main difference you see? Quickly on the equations, what do you see different?
That's not equal to 0.
Perfect. It's this side is not 0. So we need to fix that before anything else, because this section is about zero product property. You need to have a 0. This is 9, it's not gonna work. So we need to get that 9 taken care of. How? What can I do? Subtract 9. Subtract 9 and move this guy to the left as 16k squared minus 9 set it into 0. Well, I'm in trouble now. This is only 2-term. It's not like 3-term factoring. I cannot do that trial error method. Sum and product is this and that. This is only 2 terms. I need new ideas. I need new sections to check out where those kind of things show up. Okay, this is kind of similar. If I go one section back actually perfectly into 6.5, they happen here, right? Not these though. It's just like this thing or this thing. You have something squared plus minus something else. Okay, that section is about binomial factoring. I mean, binomial means 2-term factoring. There are exactly 2 terms in here, but the real method name is called square difference. First thing you need to do with these things is you need to make sure they each have a square. And not cube, sorry. And I don't see square on this one. So you need to make a square on this one. So what number 9 is square of? 3. So make this 3. What number or expression here? 1 squared makes 16k squared. 4k. So k is coming as it is. 16 needs to be converted into 4, because when I multiply 4 times 4 it makes 16. And again, this is the square difference formula from 6.5. You take 2 sets of parentheses. Whatever you see in the under the square in the first part, you put it into both places. Whatever you see secondly under the second square, you put it here. Once you use a plus, once you use a minus. It doesn't matter which order. 1 plus, 1 minus. So that's what I'm gonna do. I will set 2 parentheses. Okay. I will use 1 minus, 1 plus. All you need to do is move this term into first and second parentheses. Move that term into first and second parentheses. That's it. Okay? Now this question looks very much like question number 1. All you need to do is product A, B equals 0. You need to do, all you need to do is set each part apart and set it into 0. Alright. To leave k alone, I need to first take care of that constant number on the ends. Now 4k is alone. We'll set it into 3. 4k is alone. Set it into minus 3. And divide. Oh, not 3, of course. What do we divide with?
4.
4. We need to get k by itself. So 4 should go by cancellation. So 2 answers. K is 3/4. K is negative 3/4. Any questions? Okay, negative 3/4. Go right and 3/4. And the last one. Same dilemma. Alright, what is wrong with this question again? Still not set bin equals 0. Again, don't rush, think thoroughly. I see people trying to break this apart and set it into 0, blah blah blah, but no. You cannot use 0 product rule until you see 0 on the right side. So we need to get this minus 60 and gun on the right side. It makes 0 when you cancel them. And this minus 60 n shows up on the left side. Set it into 0. Alright, I'm stuck. Because this is cube. The first time I'm given a trinomial, 3 terms, but it's a cube. N cube, n square, n. Yeah, we need to first look, first step always, step 0. Look for something common in all terms. I see 3 common. This is 3 times 20. I see 3 common everywhere. Is that the only thing common? And 1 n from each guy can be factored. 1 n, 1 3, moving out. Right here, 3 n's all has been recruited from everybody. So this guy is gonna turn into 3 gun, 1 n gun, it turn into only n squared. 3 gun, 1 n gun, there is still 1 n left. N gun, 3 gun, what is left? Yes. It's minus sign with 20. Great. I have already a factorization here. I can set each into 0. However, I have a feeling that I can break this into 2 more pieces and I can have 3-piece factorization here. 1, 2, 3. How? How do I break n squared and minus 20? This is a 1 n squared question. This is section 6.2. Starts with 1. All you need to do is take these numbers and match them with this puzzle. Product will be minus 20. Sum will be positive 1. What pair of numbers you can take here? Their product will be minus 20. Sum will be 1. Is it minus 120? No. 1 minus 20? No. 2, 10? No, no, it's 8. No. How about 2 minus 10? No. It will take a while if I do it, so you better tell me the answer.
It's negative. 5.
-4 and 5 was actually the next thing I was gonna try, because 3 does not divide 20. I was gonna try 4. -4 and 5, and voila, exact same sum. -4 plus 5 is 1, right? Good. You take -4 here, 5 there, use n with it. Next, we set each into 0. 3n set into 0, n minus 4 set into 0, n plus 5 set into 0. Alright, how do I cancel 3? I get, what is 0 over 3? 0. You have no money, you need to give it away to 3 people, each get 0. Alright, add 4, subtract 5. -5, 4, 0. Going into, yeah. Again, you can put it in mixed order, won't matter. Alright. Any questions? And today, this is what we're gonna stop. I believe this is the last section we're gonna see in this chapter. Factoring's over, but that doesn't mean you won't be seeing it again. We will use it in the next chapters. So you already got these skills. We will put them into work in the next chapters. Okay? So chapter 7, rational expressions is what we are gonna be start doing on Friday.